This is a quick video on a little bit of reminding you how logarithms work, where you're writing them as a single logarithm or taking a single logarithm and breaking it up into the sum and difference of logarithms. You learned this in college algebra, and so it may have been a day or two since you did these. So if you need just a little bit of a reminder to go along with your logarithmic differentiation, then here is your reminder. And so let's start off with the powers. So you remember you had a to the r times a to the s is equal to a to the r plus s, and a to the r over a to the s is equal to a to the r minus s. So if you look here and kind of listen, not that we're all auditory learners, but sort of listen to what I'm saying. So if you have a base raised to power times the same base raised to power, you add the bases. So when you're multiplying like bases, you add the powers. Okay, so multiplying and adding are kind of coordinating procedures within this function. And when you divide, so a to the r divided by a to the s is a to the r minus s. You're going to subtract. Okay, so when you multiply the same base, you add the powers. And when you divide the same base, you subtract the powers. Now, so the function we're doing with adding and subtracting is on the powers. And remember that that logarithms are the inverse functions of exponential equations, right? So if you had a base raised to power equal to some result, you could switch it into log form by saying, okay, the log, and whatever your base was goes right here. This is your result. So the log of what was your result is your power. So logarithms, the logarithm of something, when you see a phrase, like the logarithm of x, this right here is actually a power. It's equal to a power. That's what logarithms are for. They find powers. That's their beauty. That's one of the things they do. They also take something that's exponentially curved and straighten it out and make it look like a line so you can predict numbers. So logarithms are great with powers, and they find powers. But remember, when you multiply bases, you add the powers. When you divide bases, you're subtracting the powers. So if I asked you to write as a single logarithm, and you had log base 4 of x plus log base 4 of y minus log base 4 of z. Now remember, they all have to be the same type of logarithm, the same base. So these two are added. Remember, they're powers, right? This is equivalent to some power, and this is equivalent to some power. And when you multiplied bases, you added powers. And when you divided, you subtract, right? So these are going to result in a division. And this is going to, I'm sorry, these are going to result in a multiplication. I was looking ahead to some days. Let's just say multiply. It fits. Okay. And this is going to be to divide. Okay. So it would look like log base 4, because we want a single log, so we only write it one time, and we have x times y divided by z, because these two, because it says plus, we're going to multiply. This is to divide. So the positives end up on top, multiplied together, and the negative ends up on the bottom as a division. All right, what if I have 2 log x minus 3 log y minus log z? So do you remember that these coefficients in the front were actually powers that had been pulled down at one time. So this pulls up like this, and you have log. This is actually understood to be base 10, but it's the same log of x squared minus log of y cubed minus log of z, right? So these two that are subtracting, all right, you could think, if you wanted to do it sort of a longer, slower, more methodical way, as minus the log of y cubed, factoring out a minus, plus log of z. So what that would do is this x squared would be on the top. This is saying you're going to divide. And these would be a product on the bottom. Divided out, okay? Or you could just say, oh, the positive ones are multiplied together on the top. The negative ones are multiplied together on the bottom. So I only have one positive one. And I have two negative ones. If I can write. Okay? And you're done. Okay? So what if you have 3 natural log of x minus 1/2 natural log of y minus 2 natural log of z minus the natural log of w. So this one is going to be in the top, and these 3 are all divided out, so they're going to be in the bottom. So I would have the natural log. This 3 is going to pull up. This 1/2 is going to pull up. This 2 is going to pull up. So you would have the natural log of x cubed over y to the 1/2 z squared w. And you could change the 1/2 to the square root if you want. Now, what if we already have a single logarithm and we want to write it as the sum or difference of logarithms? And that's really what we did in logarithmic differentiation, logarithms. Okay, is where we had, we took the log of both sides, and then we split the log of whatever that complicated part was up into pluses, minuses. So that's what we're going to do. So if we have the log of x squared y cubed over z, I'm sorry while I make noises, w to the 4th, right? So these two are multiplied on the top, right? They're a product, but since they're multiplied on the top, they are going to be positives, and these are divided out, so these are going to be negatives. So you would have log x squared plus log y cubed. Now you can think of it as minus log z plus log w to the 4th, right? Because these are a product underneath. But this minus sign is going to distribute. So it's really just as fast to say this is top, top, bottom, bottom. So it's plus, plus, minus. So there's an understood plus there, plus, minus log of z minus log of w to the 4th. Okay? And then you have to pull the powers down in front. So this 2 is going to come down. This 3 is going to come down. This 4 is going to come down. So you have 2 log of x plus 3 log of y minus log of z minus 4 log of w. Okay? So what if you have the natural log of x plus 1 squared, x minus 4 cubed over x? And I want you to write it as the sum or difference of logs. So these that are on the top are going to be plus. These that are on the bottom are going to be minus. So you'd have the natural log of x plus 1 squared plus the natural log of x minus 4 cubed minus the natural log of x. So you can bring the 2 down. You can bring the 3 down. And you have the natural log of x. Now, if you're not listening too much, you're distracted by the TV or friends or family running around or, wherever you're watching this, I need you to stop and pay attention for just a minute. I need your complete attention. All right. Now you can separate a product, right? So if you have x plus 1 times x minus 2, you can separate a product by adding. You cannot, absolutely, positively cannot, not in any shape, fashion, or form, separate this. Okay? You cannot say, it's not the distributive property. You cannot say that this is equal to the natural log of x plus the natural log of 1. This is absolutely a no, period. Okay? You can separate a product. You can separate a division. You can by adding and subtracting, but you cannot separate something that's already adding, that's inside the argument. You cannot separate this one. You cannot separate that one. Okay? This is it. The natural log of x plus 1 and the natural log of x minus 4 does not separate anymore. Okay? Please don't do that. Now, will your teachers ask you sometimes? Yes, just to see if you're paying attention and know you can't do that. Okay? Because we like to do that and make sure that you know what's going on. Okay, so what if we have the natural log of the square root of x times x minus 5 over the cubed root of x squared? And I want you to write it as the sum or difference of logs, right? So you're going to separate it out. Everything that's on the top is going to be plus. Everything that's on the bottom is going to be minus. So you'd have the natural log of the square root of x plus the natural log of x minus 5 minus the natural log of the cubed root of x squared. All right. Now remember, natural logs are related to powers, so you normally don't leave it with a square root. This is natural log of x to the 1/2 plus the natural log of x to the minus 5 does not clean up anymore. This is it. All right. You cannot separate the natural log of x minus 5 minus the natural log of x to the 2/3. Okay. So then you would have 1/2 natural log of x plus the natural log of x minus 5 minus 2/3 the natural log of x. Right? Hope that helped you to remember a little bit about the nuances of how to write logarithms as a single log, because normally that's the way it's introduced, so that it would help you to smooth the process of taking a single log and write it as the sum of difference of logarithms. So I hope that kind of brushed off some of that rust and everything from the last time you saw this, which was at least probably a semester before, if not maybe a year or more. So good luck. And you should go back and finish your logarithm differentiation video or move on to the next one. All right. And don't forget to like and subscribe. See you at the next video.